Hello and welcome to my AP Statistics series. In this video, I will walk through the entire FRQ of the 2012 exam. I have a previous video where I cover all the content in AP Statistics. It's recommended but not required that you watch that first, and I also have an MCQ walkthrough. Let's get started. So on the FRQ, you have 90 minutes to complete 6 questions, and they recommend spending about 65 minutes for questions 1 through 5, and the remaining 25 for question 6. Questions 1 through 5 count for 75% of your FRQ score. If you want to try to practice FRQ by yourself before watching the walkthrough, it is linked down below in the description. But anyway, let's get started. To save time, so this video won't be too long for you, I'm not going to write out full solutions, but I'll explain what you need to do for full credit for each part. So we have a scatter plot, and it asks us to describe the nature of the association between price and quality rating for the sewing machines. All right, so in my stats video, I mentioned there are 3 characteristics that must be described, positive or negative. In this case, it's positive because as one increases, the other tends to increase. Linear or nonlinear? Nonlinear because the relationship doesn't seem very straight, it seems curved. And weak or strong. And in this case, weak because the points don't fall close to a line of best fit. And then fourth thing, this is very important. You must provide context. And providing context is very simple. Just say that there is a positive, nonlinear, weak, and then association between quality rating and price. So as long as you mention quality rating and price, you've provided context. And then one of the 14 sewing machines substantially affects the appropriateness of using a linear regression model. So report the approximate price and quality and explain your choice. All right, so if we fit a linear line, it might look something like this. So which point would be an influential point? This point right over here, because it is both an outlier and a high leverage point. So the approximate price and quality rating is 2,265. And then to explain your choice, it is too vague to say this point is an outlier. That would not give you full credit. So to get full credit for this part, you must explain that the linear model does not do a good job of fitting the data because of this, largely because of this point right over here, or that along with this point, the data tends to follow a more nonlinear trend. So C, Chris is interested in buying one of the 14 sewing machines, and he will only consider buying those machines for which there is no other machine that has both higher quality and lower price. On the scatter plot reproduced below, circle all data points corresponding to the machines that Chris will consider buying. All right, so let's consider this point and this point right over here. This point has both the higher price and lower quality than this point. So if we circle this point, then that immediately eliminates all points that are below and to the right. And the same is true for this point. So once we circle both of these points, all the rest of the points are to the right and below one of these 2 points. So therefore, these 2 points are the only points that get circled. Question number 2. A charity fundraiser has a spin-up pointer game. All right, so a donation of $2 is required to play. For each donation, a player spins the pointer once and receives the amount of money. All right, and then the spinner has an equal probability of landing in each of the 10 sectors. Let X represent the net contribution to the charity. So complete this table for the probability distribution. All right, so the net contribution is $2 if a player makes a $2 donation and doesn't win anything. And as you can see, we have 6 slots that are labeled 0. So the probability of a $2 donation is 0.6. And then a $1 donation is made if it lands on any of the $1 cells. So this has a probability of 0.3, and we have only one $10 cell. So the probability of a net donation of -$8 is 0.1. So what is the expected value? So the formula for expected value shows up on the formula sheet. So you just sum over all possibilities of the probability times the donation amount. All right, and then you're going to get that this is equal to 0.7. Okay, so now the charity would like to receive a net contribution of $500. What is the fewest number of times the game must be played for the expected value of the net contribution to be at least $500? So the expected value of playing this game multiple times is 0.7. That's the expected value that we determined right over here, times the number of times that the game is played, 10. All right. And then we need this to be greater than $500. All right. So, or actually greater than or equal to, because it's at least. All right. And then if you solve this inequality, you'll get that n needs to be greater than approximately 714.2 ... All right. But since we can't have a fraction of a play, we have to round up to 715. So 715 is the answer. And then based on last year's event, they anticipate it will be played 1,000 times, and they want to know the probability of obtaining a net contribution of at least $500. And then the mean and standard deviation of 1,000 plays are given. So use the normal distribution to approximate the probability that the charity would obtain a net contribution of at least $500. All right, so the net contribution, it tells you to use the normal distribution to approximate it. So since we're asking at least, it would be normal CDF with the right tail. All right, so the lower bound would be $500. Since we're asking at least 500, the upper would be 10 to the power of 99. All right, and then mean, it gives you that the mean is 700, and standard deviation is 92.79. So if you plug this into your graphing calculator, you would get approximately 0.9844. And make sure to explicitly write out this answer for full credit. All right, question number 3. So it gives you some histograms and tells you there are independent random samples of 500 households for 2 different years. So A, compare the distributions. So as I mentioned in my stat video, to get full credit, you must compare the center, shape, and variability, as well as provide context. All right, so let's start off with the center. So we can do that by reporting the median. So since there are 500 households in each sample, we want to find the 250th approximately. So in this first one, we can see that we have, if we take all the numbers up to here, that would be approximately 100 plus 60 plus 40, which is approximately 200 households. So the 250th household falls in this bar right over here, which is 5. Okay, and then for the second one, it's a little bit harder to tell, but it seems like it would be, the median would be either 3 or 4. And you don't have to be exact, as long as you say approximately 3 or 4, and you compare the 2 distributions. So you say that the household size, the median household size in 1950 is greater than the median household size in 2000, which is 3 or 4, then you would get credit for describing the center. All right. And then now for the variability, we can just report the range. So the range of the household size in 1950 is 14 minus 1, which is 13. And that is greater than the range of the household size in 2000, which is 12 minus 1, which is 11. And then finally, the shape. So both of these distributions are skewed right. All right, so remember, center, shape, variability, and provide context. All right, and the researcher wants to use this data to construct a confidence interval, state the conditions for using the 2-sample T procedure, and explain whether the conditions for inference are met. So remember, random samples, and then normality of the sampling distribution. So either large sample sizes or the populations are normally distributed. All right, 10% rules. So sample sizes are less than or equal to 0.1 times the population sizes. And then independent samples. All right, so as the question mentions, the samples are independent and random, so that satisfies these 2 conditions right over here. And then large sample sizes, so both sample sizes are 500, which is greater than 30, so that's large enough for the central limit theorem to hold. And since we're considering the population of all households in a large metropolitan area, we can assume that the sample sizes, which are 500, are less than or equal to 0.1 times the population sizes. All right, so these are the conditions, and make sure to explain why the conditions were met. Question number 4 is a statistical inference question. So a survey organization conducted telephone interviews in December 2008. Okay, it asked, do you think television commercials are an effective way to promote a new product? And then in December 2007, there was a different sample. And do the data provide convincing evidence that the proportion of adults who would respond yes to the question changed? All right, so let's first set up the hypotheses. And then in my stats video, I gave examples of statistical inference where there was a clear first and second school, but here there is no clear first and second. So you need to define your variables. And we can use P1 or P like substrate 2007, but basically you need to say let it be, and then the population proportion of adults in the United States in 2000 December. So for P1, let's just do December 2007. We would respond yes to the question. All right. And then let P2 be the population proportion of US adults in December 2008 who would respond yes to the question. All right. So make sure that your variables are clearly well defined. Otherwise, you could lose points on the exam. Okay. And then now the hypotheses. So the null hypothesis is that, so since we're asking whether it changed, the null hypothesis is that it didn't change, so the difference is 0. And then the alternative hypothesis, so it doesn't specify like larger, it increased, decrease, or anything, it just says change, so therefore it would be not equal to 0. Okay? And then now what procedure would we use? Well, since we have proportions and we have 2 samples, we would use a 2-sample z-test for comparing proportions. So make sure you specify what procedure you're using, otherwise you could also lose points. All right, and then now we can check the required conditions. So first, random samples. So yes, to explain why they just you can just say they randomly selected adults. And then normality. So for this, you can just say there were at least 10 yeses and nos in each sample. All right. And then although they didn't take off points if you didn't specify the 10% rule, it's still best to write it out. So no more than 10% of the population is sampled. All right. And then to explain it, you could just say that since the population is all US adults, that's clearly greater than 10 times of our sample sizes. And then finally, independent samples. And then to explain why the samples are independent, you could just say they were from different years. Okay, so now let's obtain a test statistic. So first, let's compute p hat 1. All right, so that would be the number of successes back in December 2007 divided by the sample size. And this is approximately 0.6098. And then p hat 2 is 676 divided by 1009, which is approximately 0.67. And then the combined C is equal to the total number of successes divided by the total sample size. And this is approximately 0.6397. Okay, so now we can obtain a Z statistic. Z equals the point estimate, which is 0.6098 minus 0.6700. Okay, and then divided by the square root of 0.6397 times 1 minus this. 0.6397, and then times 1 over the first sample size plus 1 over the second sample size. So this formula shows up on the equation sheet if you can't remember it. All right, so this would be approximately negative 2.82. All right, and then now we obtain a p-value. So the p-value would be 2 times the probability that a z-statistic is less than or equal to negative 2.82. And then you can determine this on your calculator to get that it is approximately 0.0048. All right, and then state the conclusion. So I'm not going to write it out, but so since you can say that since this is less than any common significance level, such as 0.05, we reject the null hypothesis, and then make sure to specify the conclusion. So we have statistically convincing evidence that the proportion of all adults who would respond yes has changed from December 2007 to December 2008. Yep. All right, question number 5. So we are given a hypothesis test. So part A, describe what a type 2 error would be in the context of the study and also describe a consequence. All right, so remember that the type 2 error is failing to reject a false null hypothesis. So in this case, we do not reject the null hypothesis, and however, when in fact the proportion, all right, so I'll just I'll just write down P is less than 0.35 for short. But then on the AP exam, make sure you write a few sentences to explain what this means. All right, and then now we need to describe a consequence. So the question said that the council will fund more physical fitness programs only if the recreation department can provide convincing evidence that the report is true. All right, so if we don't conclude this, then the council will not fund more physical fitness programs due to the lack of evidence. All right. And then for part B, so the recreation department recruits 185 adult residents who volunteer, and then we obtain a p-value of 0.97 for the hypothesis stated above. All right, so yeah, what would it lead you to conclude? So since the p-value is greater than the level of significance of 0.05, so p-value, so yeah, make sure to write in full sentences on the AP exam. I'll just write out simple short things to make it simple. All right. So we fail to reject the null hypothesis. We do not have statistically convincing evidence that less than 35% of adult residents will be able to pass a physical fitness test. All right. And then part C, describe the primary flaw in the study described in part B and explain why it's a concern. So let's read over it again. Recruits 100 adult residents who volunteer. Okay, this is a keyword. So it's not a random sample. So yes, the participants were volunteers. And now you need to explain why it is a concern. So why could this cause our results to be biased? So, and the reason is because it is reasonable to assume that people who volunteer to take a physical fitness test are more physically fit to be able to pass it. So yeah, just explain how our sample could be different from the population, more physically fit units. All right. And then now finally explain that it is not representative of our population. So sample not representative of our population. Okay. Question number 6. So 2 students, Peter and Ronio, wanted to estimate the mean number of soft drinks that a student at their school consumes in a week. All right, we have a complete roster of 2,000 students. Peter selects a random sample of 100 students. Rania, knowing that 60% of the students at the school are female, selected a simple random sample of 60 females and 40 males. All right. A, describe what method Peter could have used to select a simple random sample of 100 students. So you should just think of any random process. The simplest one is probably a random number generator to generate 100 distinct numbers from the range 1 to 2000. And then you could enumerate the students in the school by the roster by, say, alphabetical order, and then pick the 100 students whose numbers are chosen. Part B. So it gives you a table and asks, based on the summary statistics, calculate the estimated standard deviation of the sampling distribution of the point estimator. Remember, the formula is the sample standard deviation, 4.13, divided by the square root of the sample size. So square root 100, and this is 0.413. Part C. So it gives you a table for Rania's data, and then asks you to estimate the standard deviation of the sampling distribution of this point estimator. All right. I went over this a little bit fast in my stats video, but basically the standard deviation of AX plus BY, where A and B are constants and X and Y are random variables, equals the square root of, and this is assuming that X and Y are independent, which they are because the two samples are independent. So this is equal to A squared times the variance or squared standard deviation of X plus B squared times the variance of Y. Okay, so now in that case, the standard deviation of this right over here would be equal to the square root of 0.6 squared times the variance of this point estimator. So remember that that would be the sample standard deviation divided by the sample size. So times 1.8 squared divided by 60 plus 0.4 squared times this standard deviation, 2.22 squared divided by 40. Okay, so now this would be approximately 0.198. Okay, and that's the answer. And then D, using these dot plots, explain why Rania's point estimator has a smaller estimated standard deviation than the estimated standard deviation of Peter's point estimator. So let's take a look at these dot plots. All right, so remember that standard deviation has to do with variability, and the variability of a point estimator is related to the standard deviation of the data itself. So as we can see, there is less variability within each gender for Rania's data than there is for Peter's sample. So as you can see, for females, it only goes from 0 to 7. For males, it only goes from 3 through 13. And then both of those are lower than the variability for Peter's sample. All right, so for part D, you need to explain that since there is less variability within each gender in Rania's data than in Peter's data, Rania's point estimator takes advantage of this fact by sampling the two genders separately, and therefore her point estimator has a lower estimated standard deviation than Peter's point estimator. Thanks for watching. I hope this was super helpful, and I hope that you'll check out some of my other content either before or after your AP exam, including entertaining multitasking challenges, videos for other AP courses, logic puzzles I invented, and clearly explained educational videos, which includes statistics content that's beyond the scope of AP Statistics. Subscribe for more free content or simply to support this channel. I wish you good luck on your AP exam.